As promised, let's take a look at how to solve and graph an absolute value inequality. Okay, we're going to take the same solving techniques that we did before, but we've got to decide, is this an and inequality or an or inequality? But we can't do that until we go through and simplify so that we have absolute value isolated. Okay, so step one on problem number 5 is let's get rid of that -3 out in front by dividing it out. Okay, so we're going to have the absolute value of 5 minus 3x. The inequality is going to flip around because I divided by negative, and then we're going to get a 4. And now I need to decide, is this an and or an or inequality? So if absolute value is greater than 4, absolute value is more than 4. If I'm doing an absolute value more than something, more means it's an or inequality. So we're going to write 2 separate inequalities, and we're going to say that this should be an or graph when we're done. Okay. Case 1 is when I just drop. 5 minus 3x is greater than or equal to 4. Okay. Now, when I do the second case and I negate, I've got to be careful. Now, if I negate the inside, I just write -5 plus 3x, and it's still greater than or equal to 4. That's my recommendation, is that you negate the inside of the absolute value. Okay. Now, if you negate the opposite side, be very careful. If you negate the opposite side, this would be 5 minus 3x. Because I'm negating outside, I would have to flip this around. And it is so easy to forget to flip it around that we might be better off going with this route so we don't have to remember that extra step. There are already a lot of steps to these. So let's try to get rid of that extra step. So I'm actually going to change and not do that second case that I wrote. So I'm actually going to get rid of this because I think it's going to be more confusing. And we're going to go with this option, okay? Now I want to solve each of them. So over here on the left, I have -3x is greater than or equal to -1. And I'm going to divide out the -3 to get x. I'm dividing by a negative, flip it around, and I'm going to get +1/3. Negative over a negative is a positive. Okay. Now when I solve the other one, I'm going to get 3x is greater than or equal to 9. And when I divide out the 3, I don't need to flip the symbol around because I'm not dividing by a negative. Keep in mind, it's x is less than or equal to 1/3, or x is greater than or equal to 3. And now I want to plot this on a number line. Again, I just need to plot the 2 numbers of interest. The smaller number needs to go on the left, that's the 1/3. The bigger number needs to go on the right, that's the 3. These are closed circles because there are equal to's. Now in OR graph, anything I can graph, I get to keep. So x is less than or equal to 1/3, less than goes to the left. And x is greater than or equal to 3 goes to the right. And this is my final answer. So this is what you would be providing for a final answer on a test. And if you do not write the word or in between, you probably will lose a little credit because you need to specify if it's an and or an or problem. Okay, on to number 6. So for problem number 6, again, I need to isolate the absolute value before I can do anything else. I'm going to subtract the 4 to get -3 absolute value of x plus 2 is greater than, subtracting 4 gives me -6. And now I'm going to go through and divide out the -3 to get absolute value of x plus 2 is less than 2. And the reason that inequality flipped around was because, again, I was dividing by -3. So I flipped it around, okay? So now I'm going to break into 2 cases. I'm going to do x plus 2 is less than 2. My second case is going to be -x minus 2 is less than 2. All right? I'm going to negate the inside so I don't have to worry about flipping the symbol. But I've got to decide now, should this be an and graph or should this be an or graph? I have absolute value is less than 2. Less than is the and situation. More means or, less than means and. So I'm going to write that this is an and inequality. So I should be getting some overlap in order for there to be an answer here. All right, on the left side, x plus 2 is less than 2. Subtract the 2 and you get x is less than 0. On the other side, I'm going to have -x is less than 4. Divide out the negative to flip the symbol around and get -4. And again, this is and in between them. Okay, so now I want to make a number line. Mark my 2 numbers of interest. Again, the smaller one on the left, that's the -4. The bigger one on the right, that's the 0. These are open circles because there is no equal to in this inequality. X is less than 0, goes to the left. Okay. X is greater than -4, goes to the right. So it's going to be the overlapping situation. Really what's happening here is I'm going all the way this way and all the way that way. So in the middle is where they're overlapping. Okay. So this would be my final answer if this were a test problem. The nice thing about absolute value inequalities is that you don't have to check your answer like you had to do with the actual equations. All right, let's go through one more problem like this together. Problem number 7. Now we've got variables on both sides, which we know is sometimes going to lead to a special case. Let's see what happens here. All right, the absolute value is already isolated, so I can split into my two cases right away. X plus 2 is less than 2x plus 7. And then my second case, I'm going to do -x minus 2 to negate the inside of the absolute value is less than 2x plus 7. Okay. Now, should this be an and or should this be an or? I have absolute value is less than the other side. Less than is an and. More than is an or. So this is going to be an and inequality. Now, I want to solve each one on its own. I'm going to subtract the x to get 2 is less than x plus 7. Subtract over the 7. X is greater than -5. So I'm going to flip that around. Sometimes it's easier to read it, but you always want to read from the x. Okay. On the other side, I'm going to add the x over to get -2 is less than 3x plus 7. Subtract over the 7 to get -9 is less than 3x. Divide out the 3 to get -3 is less than x, or x is greater than -3. And now I need to go to a number line. Mark my two numbers of interest. Keep in mind that this is an and inequality, so we're looking for where they overlap. My numbers are -5 and -3. I have x is greater than -5. I have x is greater than -3. And I want to know, well, where do these overlap? Well, they overlap from -3 on. So this is one of our special cases from a compound inequality. So the final number line is actually going to be just the greater than -3. So I'm still going to mark both numbers. Oops. That should be purple, Miss Morrow. -5, -3. This is my final graph over here. So my final answer will be this. Like that, okay? That's my final solution set. All right, now, quick follow-up. If this had been an or, and if this was the number line, I would have done from -5 up instead, because it would be anything I can graph I could keep, so it would have been from -5 up instead. All right, but it wasn't and, so I needed the overlap, okay?